Okay. Hello, everyone. Thanks for being us here today. We are going to talk about TypeScript compiler. It's a topic about talk about the internals of TypeScript compiler, and a topic where a usual developer doesn't need to know, but I think it's an interesting topic to discover today. And I hope you will enjoy the trip. Before I start, I will just present myself. I'm Vincent Ogloblinsky. I'm a software front-end architect at S2I in France. We are building big web application using Angular, TypeScript, HTML5, and powerful APIs inside the web browser. I have put in this link sketch notes of the talk. If you want to have a break and just listen and don't make notes, you can enjoy the sketch notes. I will share the link at the end also. What we are going to see today, we are just starting with what is a compiler, how it works. After we'll see how the TypeScript compiler works internally. After we can have a look at what can we do with the IST we'll get from this compiler. And after we'll do watch 2 demos and having some fun with IST. First, so what is a compiler? A compiler is a computer program that transforms a source code writing in one programming languages to another computer languages. If we put that with a graph, you are going to move from a human readable code base with a high level of abstraction, and after the compilation you will get a computer readable code with a low level of abstraction and very close to the final virtual machine where the code will run. The different levels are very important, and sometimes there is a confusion between compilation and transpiling, which is himself different, because transpiling, you are starting from here ECMAScript 6 code base, and you are switching to ECMAScript 5, so you are very close and you have the same level of abstraction. In compilers, you are not. You are a very important level between the two parts. So, what is the process of a general compilation? There are 3 simple steps. We'll see later in details. There the parsing phase of your code, after a transforming phase, and after a generating phase. The parsing phase will start by taking your raw code and turning into a more abstract representation. And this phase has 2 steps. The first one is a lexical analysis of your code, and after we have a syntax analysis. The lexical analysis will try to parse your code and split the statement into tokens to create a very big stream of tokens and prepare the stuff for the next part. Syntax analysis will take this stream tokens and try to start building a representation of each part of the token we have, the syntax and the relationships with each other. And after, when you start with this, for example, this array of tokens, you will get after the famous abstract syntax tree, which is a tree which more easily to parse and to understand the structure of your code. After that, the transforming part will take this IST and make transformation around all the nodes we have in it, and printing and starting the stuff for the final language you are targeted, for example, for TypeScript, and adding, we will see symbols and extra information. And the last part is the output of the code in the desired languages, for example, ECMAScript 5 or another target. And the generator will just stringify your nodes and it knows how to print them. And you will see later in a TypeScript example. So with these 3 parts, TypeScript will enhance the second one, and you will see that in details now. The same process for TypeScript is just by adding the type checking phase for your code and doing some semantic checking. TypeScript, if you look at the source code, we have a very deep layer of abstraction. You have at the bottom one the core TypeScript compiler APIs, and after we have also other one like languages services we use in IDEs or the TSC server, etc. The first part of TypeScript compiling is to scanning your code base and creating the token stream we see before. The scanner is driven by a parser, we'll see later. And if we try to set up just a little boilerplate with all the internal APIs, we are here requiring TypeScript, creating a scanner, and after looping and scanning using the scanner.scan API to create this token stream. And after that, you will get I just print a few examples here. Information about the tokens you get from your source code. The example, the source code is just a one statement, but it's just for the demo purpose. After that, the parser will take this token stream and will try to generate the famous AST. The parser is driven by a program we will see later in the next slides. And this parser, you can use it if you want by creating a source file using ts.create source file API. And you will get, if you print the result of this call, the famous and the most AST object, which is a big an enhanced file and object you will get with all the nodes, and you will see some of them later. If you want to parse and navigate inside very easily, you can use a tool called astexplorer.net, where you can, for example, navigate and directly get the result of what code you have written on the left side and try to debugging or playing with that. The next phase after the parsing, we have the AST, and the binder here will try to start the first semantic pass of TypeScript and trying to connect each node with their relationship. And for that, it just creates symbols. These symbols are a connection declaration between nodes, which will contribute to enhance, for example, nodes who are related to the same entity. And it's the first part of the TypeScript internals checking. If you use, for example, this the previous parsed source files we get from the parser, we supply it to bind source file API, and the binder will enhance our AST with all symbols it will found inside. The next phase is a checker, which is driven by a program we'll see next slide. It is the most important part of the compiler, the file in the source code file on TypeScript GitHub repository, around 2 megabytes, so very, very huge. And it is going to do the most important part by doing the semantic pass and figuring out relationship between symbols, assigning types, and also doing a semantic diagnostic and printing errors if we have some in your code base. For example, we are here creating a program. It's the main API which will be used in all the tools we will see later. We are here configuring it to say we don't emit the file if there is an error. We will see later why. And you can call, for example, an API, a public API of TypeScript, get pre-made diagnostics, supplying the program, and you will, for example, now get an error about the assignment of a number inside a string inside a number. The last part is logically the emitter will try to generate your code. In the desired output, it can generate JavaScript, declaration files, or source maps. It will use an emit API of the program we have seen before. And internally, you use a transformer and knows how print each node in the correct syntax in the final file. And if you use the previous example and try to emit the file, we will get an error. And the result would say you cannot assign a string inside a number. And the code base will not be, the final file will not be generated. And if we just fix our error in your code base and putting a number inside a number declaration, the result will be empty and you will get your file. With just this for few slides, we have seen internal APIs of TypeScript compiler and how you can do yourself if you want the same stuff as TSC CLI of TypeScript does. But after that, the main purpose of TypeScript is to compile your code, but you can do also other stuff with your AST. And we will see some stuff you can do with AST now. The first stuff you can do is analyzing your code just by, for example, linting, analyzing complexity, generating documentation, or checking API conformance for your internal rules, for example. If we see in detail linting, for example, with TSLint, this tool use internally TypeScript compiler APIs. And if, for example, you enable a type checking option in TSLint, it will not just trying to lint your code with syntactic checking, but also doing some semantic checking with default rules or your own rules you created before. And if you don't enable this option, you will just trying to lint your code, parsing your AST, the AST of your files using an internal worker and internal APIs of TypeScript compiler. And if you want, you can enable an option to fix your code directly. And TSLint will try to apply patch on your code in your AST directly. If you want to play with AST and TypeScript compiler directly, without having to understand all the low-level APIs, you can use a project called TS Simple AST from David Chevet, which is very powerful, and you can, with this wrapper, easily manipulate and navigate inside the AST, adding nodes, removing them, edit them if you want. And you will see an example later. Another stuff you can do is generate documentation of your code. The famous project for that for TypeScript is TypeDoc. It's like ESDoc or GSDoc for TypeScript, and it will generate static HTML pages of your code, of your TypeScript code with all the information about your properties, your class, your interface, etc. If you want to go deeper in with your TypeScript code base or more for details in your Angular application, I have created a tool last year called Compodoc. You can start with it and generate a dynamic documentation of your code and your Angular application. It is the same process as TypeDoc, but it will add some dynamic information about, for example, your models, how many components you have. For example, you can have information about the metadata of your sorry, the live slide is here. You can have your graphics graphics information about your models, about one model, for example. If I try to open a component, you also have a more complex. You can have information about the metadata, the templates, the inputs, the outputs, all the internal Angular APIs you have in your code base, and external stuff like your directives, injectors, etc. And you also have a documentation coverage to see if you are correctly document your code. And one big challenge I encountered during this project was to deal with during the parsing of all the files. We are printing a router graph, you will see in the next slide, and dealing with dynamics imports of routes metadata, or it's the same process for components metadata or directives, was a little difficult. Because if we look at this example, we have in the route definition a path.home reference, which is not directly a string we've usually used inside our code base. It's inside TypeScript compiler reference. It's a property access expression. And we don't want to use directly this value for printing the routing, for example, and we want to have directly the value of this import. By using the project we have seen before, TSSimple AST, we can manage to detect that it is a dynamic value, and trying to find it inside our imports or local variables of the files. And if it's from an import, you can parsing the path. For here, it's home-path, and get the final string value we want, and can, with that, edit the AST node of this route definition and add the correct string. And after, you can get this kind of graphics where you can see all the routing of your application without dealing with going inside your file, etc., your definitions. So it's a good example of playing with AST and managing all the stuff and all the APIs of TypeScript. Another tool you can use is ngrev from ngrev, where you can easily navigate inside the code base. With Compodoc, you have a static HTML pages. With that, you can easily navigate inside your model and after get information about the component, etc. And it's very powerful tool when sometimes you go inside a new project and a very big code base, and you try to understand how it works. The other stuff you can do, we have just trying to playing a little with the AST of your code base, but sometimes you want to transform deeper the code, and the transforming can be done like transpile your code, generate other kind of code from a first code base, pre-process it or reformat it. And for example, if you want to edit the code, the most famous tool that use TypeScript compiler APIs inside is Angular CLI with schematics projects. For example, if you see and watch the source code, when you generate with the CLI a new component, it will add a declaration of this component in your model. And internally, they will use TypeScript compiler APIs to edit the AST node of the declaration and try to find which array it is, and after adding your declaration inside. So it's also a good example of AST manipulation. We have also Angular build optimizer, who himself is doing a very huge stuff around your code during the build, and trying to parse all the AST, trying to generate an AST from the templates, etc., and try to add this kind of pure comments of down-level TypeScript classes, and preparing the stuff for the dead code elimination, which will be done with Ogloblinsky or Google Closure compiler. So it will also edit the AST before the emitting phase we have seen before. You can also directly, when you are live coding, transforming your code without knowing you are using TypeScript compiler APIs. Preacher, for example, is a good example, which is an opinionated code formatter. And when you hit save in your IDE, it will parse your code, get the AST of the file, and reprint your final code with a correct syntax and a correct design, and a better way to figure out with tabs or space, etc. It's a good tool to easily see what you can do with AST every day. So now we have seen general stuff from our everyday tooling, but for this talk I'll try to find interesting demo to play with the AST to make more funny. So my first demo is about how we can handle huge code base when you come inside a project. For example, we have a very deep code base with very many files, many models, many folders, etc. And one question we can try to answer was, what are the relation between all these files? Is there one or two who are not used? Is there one which is the most used inside the application? And we'll try to take care of it. And for that, there was a famous tool called Match from Patrick Henningsen, which is very cool to generate a static 2D graph of the link between all the models. It plays very well with X6 models or CommonJS, etc. And it works also with TypeScript files. It's not directly put in the documentation, but it works very well. And you can get, for example, this kind of graphics at the end. But it is a very simple example, but if you have more files and a very complex structure, it's not very easily to navigate inside, because as the files will grow, the graph will be more and more larger, and difficult to visualize all the stuff. So I tried to say, maybe can see it in 3D, and maybe try to extrude these graphics to have a more interesting example. So I just opening demo. Sorry, it's here. So it's a tool called just Match 3D, which is will be using Match inside in the stuff it is doing. Match will generate a JSON file with all the relation between the file, and we're just printing them in a more 3D world to see if we can see a more deeper and more easily the structure of your application. And after that, you get this kind of demo where you can, I will open quite deep, larger the screen. You can easily navigate inside, or maybe you can easily see which files are using, which files are not used inside. Some of them are just files were not imported. We have an example here of maybe if I try to zoom a little. This kind of part is a lazy model of the Angular application. So it's a group of files where it's not connected with all the other tree. And you can, for example, see that here inside, if I try to zoom closer. I hate trackpads. It's not really. Oh, sorry. There is a file here, which is the most imported file in your code base, which is a model of, it's a to-do list application, which is a model of a to-do. But you can also see other imported file here. There is a group here where you can have focus and try to test it and say it's the most important part of the project, and maybe you can have doing some testing, etc., to don't have problem here. But it's for daily. It can be for daily tuning if you want. I have set up a little demo on this GitHub repository if you want to play later with it. It's not ready for production and for big project. It was just a proof of concept, but you can play with it. We also love music, so I tried to think about a demo about how we can play with AST and make sound with it. So I hope it will work too. So for the next demo, I hope the sound is correctly connected with the. So this demo is just, I call it TypeScript AST soundtrack. The idea is to use this editor we have here. I have just mapped, just for the demo, all the decorator of Angular, like host binding, input, output, etc., of my variables inside my component, and mapping them with music notes. And we'll try to play with this code base. We'll use a TypeScript compiler to get the AST of this file. We will focus on the inside of the class of our component, and we will play with all the nodes and try to have some fun with it. So maybe if I hit the play button, we can have some sound with it. It's not very very beautiful, but I have a little selector here when I can select, for example, an anthem. For now, I will start with the French anthem. I don't put all the notes of the anthem, just a few seconds, because it's very long. And you have seen that the code base of the editor was enhanced with a lot of stuff. It's not a ready component production, but it's just for the demo. And after that, we can easily have some better sound. But we are in Belgium, so we can play your anthem too. Okay, that's it. I don't put all the notes, but it's both for the demo. So that's it. You can do what you want with the AST. You can play sound. You can do a very funny tooling. If you want to play with it, there is a GitHub repository here. For the conclusion, I will say TypeScript is a very cool project. We all love. Sorry, where is my mouse? Here. We all love TypeScript because it's enhanced since the beginning our code base. And during the preparation, I asked a few people from the libraries and tools we have seen before their feedbacks about how they deal with TypeScript and the compiler APIs. And here are the feedbacks. The cons from the community are, most of them are just by the extra compilation steps that add TypeScript during our everyday usage. It's a little gap. If the project is bigger, you can have some seconds to wait, but there are many projects and many stuff done by, for example, the Angular team with Bazel compiler, which will help us every day. There is a JavaScript library integration, which is a little complicated sometimes when you have a declaration who are not very close to the final library source code. And sometimes, for myself, there is a lack of documentation for the internal APIs, but if you go on GitHub and you watch all the other tools, you can easily find a solution, but there is stuff to do here. The pros from the community, we have, with TypeScript, refactoring quickly and safely, thanks also to TS language services. We can generate more attractive code from our team and for people who are coming inside our projects. Another stuff is thinking with type, make our code more precise because we have all the information, we just have to read. Don't try to get information for just watching the documentation or trying to watch the auto-completion documentation, for example. And also enhance our maintainability and readability of your code. And can easily, now with Vincent 2, enhance your JavaScript code base gradually. You can migrating your code base, your old legacy JavaScript code base easily with TypeScript. And also it will open front-end community to other developers from Java, C# or .NET. And it was very cool for that too. And the last part is great editor support, which also boosts our productivity. So for me, the future is bright for TypeScript and for JavaScript. I think JavaScript will be more virtual machines than a language when you start from TypeScript and finishing with JavaScript code. We don't write JavaScript vanilla.js. We are writing a high level of abstraction with TypeScript code, and you get at the end a JavaScript file. Frameworks will also move from runtime libraries into optimizing compilers. You have a good example with Angular, but also with in JavaScript community with stencil.js for TypeScript, etc. Or there is a project by Rich Harris, I don't remember the name, but or maybe I will find later. But the idea is to moving from runtime libraries to generating, compiling code and outputting very JavaScript code base very close to the final virtual machine where your code will run. I have put some resources here if you want to have more information about the official documentation or very good articles on Medium. Also here links about the rise of TypeScript, how it is moving, feedbacks from, for example, Slack, how they're migrating their old legacy code for the application to TypeScript, and other articles if you want. I hope the trip was very interesting, and thanks for listening.